Okay, so here it is asked find the equation of the curve which is passing through the origin and whose differential equation is this. So y dash, it is given y dash equals to e power x sine x. Okay, so it means that it is dy by dx that is equals to e power x sine x. So we can write it as dy that is equals to e power x sine x into dx. Okay, so then we have to integrate on both sides. So now here we have to do the integration by parts. Integration by parts. So here we have to use that eyelet rule. Eyelet means which one I should use as the first function. Mm, So here it is inverse trigonometric, then logarithmic, algebraic, trigonometric, and exponential. So exponential, I should take it as the second function. Okay, so we know that in the integration by parts, we know that the rule is that if we have like integral u v dx, then if v is the second function and u is the first function, then we will do u integral v dx minus integral du by dx integral v dx, then whole of that integral dx we have to do. Okay, this is the formula for integration by parts. So now here we have to take this e power x as the second function, that is the v function. So integral dy is y, so then we will do sine x integral e power x dx, then minus I will do integral d by dx of sine x into integral e power x dx, then whole of that integral dx. So that will be equal to sine x times e power x minus d by dx of sine x is cos x times e power x, then that times dx. So now uh, this is I. So now actually let's say this is I, this is the integral of the of this function. If I tell the integral of this function is, suppose if I take it as I, then I will be equal to this. So I will be equal to, I can write e power x into sine x, then minus, then again I have to do the integration by parts. So that will be cos x integral e power x dx, then minus integral d by dx of cos x, then integral e power x dx, whole integral dx. So then I will be equal to, I can write e power x into sine x minus that will be e power x cos x, then minus this will be your, so d by dx of cos x is minus sine x, so that will be plus sine x, plus sine x, then integral e power x is e power x into e power x integral dx. So this is again your I. So I can say that is I equals to e power x times sine x minus cos x, then minus I. So it means I can tell 2i will be equal to e power x into sine x minus cos x. So therefore I can say the integral, the value of this integral will be e power x by 2 sine x minus cos x. Okay. So now integral dy is y. Therefore, the general solution of this given differential equation is y will be equal to e power x by 2 sine x minus cos x. Sorry, this will be minus sine x minus cos x plus c. So now c is the arbitrary constant which can be removed by the fact that it is given that it passes through the point 0, 0. So 0, 0 will satisfy this curve, will satisfy. So x equal to 0 if I put, then y will be 0. So I can tell 0 will be equal to e power 0 by 2 into sine 0 minus cos 0 plus c. So we can say that e power 0 is 1 and sine 0 is 0, cos 0 is 1. So I can tell the c minus half, that is equal to 0. So it means c will be equal to half. Have you understood? C will be equal to half. Okay. Yeah. So therefore, the answer we can write, that is your 2y, that is e power x times sin x minus cos x plus 1. So this is the final answer. Means this is the required particular solution. This is the required particular solution of the given differential equation. Okay, thank you.